Hello and welcome to Hoopla Kids Lab, making science super fun and super simple. Today we're showing you the Mentos skateboard. You're going to need a small skateboard, some Mentos, a roll of tape, and a bottle of Coke. Firstly, take your bottle of Coke and lay it onto your skateboard. Have someone help you hold it in place and then tape it around the board so that it's nice and secure. You need to make sure that the bottle stays in place. Once you're sure that's done, take it outside. Go into a wide, clear area and drop a few of the Mentos inside the bottle of Coke. As you can see, the first time I did this, it was a total fail. So what can we do to help this? Well, my theory is that if we create a smaller hole for the liquid to escape, the pressure will be higher and the bottle will launch faster. I'm also going to try and make a loading mechanism out of the Mentos packet. Let's remove the paper part. Roll up some Mentos, tape one end closed, and then twist the other end. Now let's get outside and try it again. Remove the cap. Make sure you're ready to go. Place the Mentos inside, screw the lid on, and off we go. It's worked! That's a great way of showing the Mentos and Coke reaction. Today, we're going to be looking at the strength of paper. For this experiment, you're going to need a tray, some sheets of paper, a pair of scissors, and some sellotape. For your first go, fold one of the pieces of paper in three. Then trim off the edges. Once you've done that, take the strips apart and roll them up tightly to create tubes of paper. Make sure it's rolled tightly and then use some of the sellotape to stick the tube together. Once you've got your tubes, take your baking tray, lay the tubes out roughly in the same shape, and then lay the tray on top of the tubes. It holds the tray up. Great! But how much more weight can it take? Well, let's put this weight on top. It weighs 2.5 kilos, and it seems to be holding it up just fine. Pretty cool, huh? Let's try another weight. Let's just rest it on top. That one didn't work. But I think it was because of the shape of the table rather than the tubes. So let's take this to the floor. And we'll use a few more tubes this time. I've also made them slightly shorter, which should hopefully mean that they wobble less. Lay them out on the floor and space them as equally as you can. Place the tray carefully on top and add your first weight. No problem. Let's try another weight. Yes, that seems to work just fine. Let's try a little more weight. Yes, amazingly, a few pieces of paper can hold up my entire weight. That's about 80 kilos. I'm very pleased. Let's try and add even more weight. There's 5 kilos worth of weight, plus me makes 85. I can even balance on one leg. This works because tubes or cylinders tend to be the strongest shape for a structure. This is why you'll often find tubes used in the construction of bridges and other massive structures. And that's how you can test the strength of paper. Today we're going to show you the can crusher. You're going to need a frying pan, a bowl of iced water, kitchen utensils, and some tin cans. First you need to heat up your pan. Then take your cans and place them on the surface. Make sure there's a small amount of water inside. This will help the cans to heat up. After a while, you should see some steam starting to rise out of the top of the cans. This way you know that they're getting hot. You could pop a thermometer inside and see what the temperature's like. While that continues heating up, place your bowl of iced water on the table, then carefully remove the can from your hot pan, turn it upside down and place it in the water. You'll see that it instantly crushes itself. This is because of the difference in pressure between the hot air trapped inside the can and the cooler air on the outside. The iced water helps to rapidly change the pressure. And there you have it. That's how you can make a can crusher. Thank you for watching. I hope you enjoyed today's experiment. Don't forget you can check out our channel for more exciting science and leave us any comments for things you'd like to see. Bye for now. Today we're going to show you how you can make a sugar kaleidoscope. You're going to need a glass, a polarization filter, a spoon, a torch, some sugar, and a measuring jug. Measure out about 100 milliliters of water. Then pour a few spoonfuls of sugar into the water. You want to add lots of sugar to make the water turn cloudy. Use the spoon to mix the sugar and water together. Then microwave it for about a minute. Stir it, then microwave it again, and repeat this process until all the sugar has disappeared. Then fetch your polarization filters and your torch. These filters will come with many cameras, or you can buy them quite cheaply online or from a camera shop. Some of these filters will screw together, which helps you perform your experiment. You can see that if you put one in front of another and then turn one of them around, it changes the colour of the light. If you place the filters in front of a torch, this enhances the effect. But now we're going to shine the light through the sugar water. Place your torch behind the jar. I've rested my torch on a sponge to make sure it's not sitting right on the table. Then put one of your filters between the torch and the jar. Pour your sugar water into it. Make sure there's plenty in there. Then position your second filter on the other side of the jar. If we turn down the lights, you can see this effect much easier. As we rotate the filter, the colour of the jar seems to change. This is because the filter is literally filtering out different colours of light as we turn it round. If we turn the lights right down, you can really see this effect happening. This is a great little experiment to play with light and colour. To make it different, you could try using a more powerful torch, or you could try using more than 2 filters. You could even try using a coloured torch to see what happens to the colour of the light. Why don't you see what colours you can make? And there you go! That's how you can make your own sugar kaleidoscope. Today we're going to show you some sugar magic. For this experiment, you're going to need a spoon, a plastic cup, some lemon Kool-Aid powder, sugar, and some water. The first step is to put a heaped spoonful of sugar into your plastic cup. Then empty the packet of Kool-Aid powder into the sugar. Mix the two together and very quickly it will just look like a cup of sugar. Then simply add the water. And hey presto, your sugar has turned yellow. This is a really great and really simple trick that you can try on your friends. You can challenge them to make sugar change colour, and then show them how it's done. And there you have it. That's how you can make sugar magic. In today's video, we're going to show you walking through paper. All you're going to need is a piece of paper, a ruler, a pair of scissors, and a pen. The first step is to fold your piece of paper in half lengthways. Then take your ruler and your pen and make a series of marks at 2 centimeter intervals along the piece of paper. You'll be left with a small amount of excess. Simply trim that off. Then turn your piece of paper around and make similar marks on the other side. You should end up with this pattern. Then start to trim using these marks as guidelines. It's important that the first trim line that you make is on the folded side of the paper. It might be best to get an adult to help you with this part. Cut most of the way along the paper, but leave about an inch of space at the end. Once you've completed these lines, carefully trim away most of the folded edge of the paper, leaving the very first and the very last piece. You'll see why in a moment. Then go to an open area. Carefully unfold your piece of paper, and you'll see that by cutting it the way that you have, you've created a massive loop that you can easily walk through. This is a great party trick, because if you challenge someone to walk through a piece of paper, no one's going to be able to do it, except you. Do be careful though, because you might tear the paper. It's hard to believe that this enormous loop is made from just a single sheet of paper. And there you have it. That's how you can walk through paper. In today's experiment, we're going to show you how you can make a slow motion ball. This is a really fun experiment. All you're going to need is a movable flat surface like a tray, some honey, and a clear plastic ball with a weight inside. Firstly, open up your ball and take out the weight. The ball doesn't need to be clear, but it will help you to see what's happening inside. Then squeeze some honey into both halves of the ball until they're about halfway full. Then place your metal ball back inside. Carefully and quickly reseal the ball. You'll see that the metal ball inside moves very slowly around. We chose to use some sellotape to make sure that our ball wouldn't open. You can do the same if you like. We got this ball inside a Christmas cracker, but you should be able to find one in all sorts of different places. Then take your flat surface, place the ball at one end, and raise it slightly. You'll see that the ball starts to roll, then slows down. It might even stop for a few moments and then start rolling again. This is really strange behaviour, but it happens because the weight inside of the plastic ball is constantly moving. Just as the ball starts to roll forward, the metal weight remains at the back, and so it stops it from rolling. You might have seen this before in trick golf balls. If you try and roll the ball along a flat surface, you'll see that it won't roll in a straight line. You can have a lot of fun with this one. And that's how you can make your own slow motion ball. We're going to show you how you can make a battery train. You'll need some neodymium magnets, batteries, a pair of scissors, and some copper wire. Firstly, pull out a length of copper wire and wrap it around one of your batteries. Make sure that the batteries are AA batteries. Continue this process. Curl the wire all along the length of the battery until you've got a good long spring. Then fix a few magnets onto each end of the battery and place it inside one end of the wire. You'll see that it seems to pull itself through. You can make a much longer length of this curled wire and see how the battery travels through the middle. This works through a combination of electric currents and magnetic fields. This is a really great and simple experiment. That's how you can make a battery train. Today we're going to show you how to make an underwater wick. For this you're going to need some sparklers, some electrical tape, a lighter, and a beaker of water. The first step is to open up your packet of sparklers. You should have 5 or 6 inside. Separate them and use some tape to wrap most of one of the sparklers in tape. You want to cover the part of the sparkler that lights, but not the very tip. Once you've done that, light the end, and once it's properly lit, drop the sparkler into some water. You'll see that this uncovered one goes out straight away. Now let's see what happens when we put the wrapped one into the water. The sparkler is lit, and in it goes. It still goes out, but after a slight delay. Now let's see what happens if we wrap 3 sparklers with tape. You might find that one strip of tape isn't quite enough, so I used a couple in this case. Now let's light these and see what happens. Into the water, and look what happens. The sparklers keep on burning. If anything, they burn really fast. If we look from the side, we can see the reaction happening much more quickly than it normally would. The reason they keep burning is because by wrapping them in tape, you're also trapping a small amount of air inside the beaker, which allows the sparklers to keep on burning. We tried this again with 5 sparklers, and the reaction was incredibly fast and quite violent. Do be careful when using the sparklers. I wore a glove just to make sure. And there you go. That is how you can make an underwater wick. In today's video, we're going to show you some floating ball magic. Now, if you look closely, you'll see I have 2 pieces of card sat in front of me. If I place my hand behind, ta-da! A ball! I replace the ball. I move the card. I show you there's nothing in my hands, there's nothing hiding. I place my other hand behind the card, and hey presto, there's the ball. Oh, but the ball's hiding behind the card, you say? Really? Can you see it? If I move both pieces of card, you can see it's not hiding. I'll move them apart for you again, and you can see there is nothing hiding. Now, if I put the pieces of card back together and place my hand behind them, yes, it's the ball again. I know what you're wondering. How am I hiding the ball? It's just floating there. But not by magic. We're using a hairdryer. A hairdryer creates a vortex of air, which when pointed upwards will support anything very light within it, such as this foam ball. So there's the trick. Now, go and show your friends too. And that's how you can create floating ball magic. In today's experiment, we're going to show you growing and shrinking eggs. You're going to need 2 eggs, some distilled vinegar, honey, 2 small cups, and a large cup. Place your eggs inside the large cup. Then completely cover them with your vinegar. Straight away, you'll start to see bubbles form on the surface. Place the cup to one side for a few hours, or overnight if you prefer, and then come back to it. You'll see that layers of the shell are starting to peel off. If you rub your thumb along the outside, you can see that it's changed colour. If you squeeze it, it feels very soft. Soak the eggs in vinegar until they're completely soft. Once that's done, place 1 egg inside a small cup and cover it with more vinegar. If you like, you can mark the cup with a V. Then place your second egg gently inside the other small cup and completely cover it with the honey. The honey is thicker, so this might take a bit longer, and you might need to move the egg around inside the cup to completely cover it. Make sure that the egg sits in the middle of the honey. You may need to use something small and slightly heavy to weigh the egg down, as it might float. We use this small glass. Then place both of your cups aside overnight. Rinse them out in the morning and see what you've got. You can see that the egg that was sitting in the honey has changed colour and turned to the same colour as honey. The egg that was sitting in the vinegar has gone transparent. You can see the yolk of the egg in the middle. But you can also see that the eggs have changed size. This is because soaking the eggs in vinegar breaks down the shell and means that the eggs are able to absorb more moisture through something called a membrane. This is the soft, squishy thing on the outside of the egg. You'll note that the vinegar-soaked egg bounces much like a bouncy ball. If you hold the honey-soaked egg, you'll see that it's also shrunk slightly. You can even feel the yolk sitting in the middle of the egg. This one won't bounce either. You can compare the two next to a normal egg, which will really illustrate how they've changed size. The honey-soaked egg is smaller, and the vinegar-soaked egg is larger. This is a really cool experiment. Why don't you try it with some other liquids to see how it affects the eggs? Perhaps milk or a soft drink. You can even pick up the honey-soaked egg, which feels really strange, like a tiny water balloon. And there you have it. That is growing and shrinking eggs. In this experiment, we're going to be showing you the chemical chameleon. You're going to need a stirrer, sodium hydroxide, potassium permanganate, sugar, a beaker of water, and a flask of water. Take your sugar and your sodium hydroxide and pour them into your beaker of water. Use your stirrer to stir them together. Then pour some of your potassium permanganate into your beaker of water. You'll only need a few grains, enough to make the water change colour. Make sure this is mixed thoroughly. Then pour your sodium hydroxide mixture into the flask. You'll see that the solution changes colour from purple to a bright blue, then green, then yellow, and then a bright orange. This colour change happens because of the strange chemical interaction between the mixtures in the glass. Viewed from above, it's a really strange combination. And there you have it. That is the chemical chameleon. Today we're going to show you the science of a plasma ball. All you're going to need is a plasma ball and probably somewhere to plug it in as well. Once it's plugged in, switch on your plasma ball and straight away you've got some amazing science happening. The ball is comprised of three main parts. There's the sphere on the outside, there's the conductor on the inside, and filling the ball is what they call noble gases. This helps to create trails of plasma. The human body is able to conduct electricity, so when you touch the side of the ball, the electricity is conducted towards you. This is why when you touch the ball, the colour and the intensity of the plasma light seems to change. You can try using different parts of your body, and you'll see that it works much the same way. If you try using other objects like a pencil, you'll find that they do attract some electricity, but not as much. The great thing about this is that you can use lots of different objects, made of different materials, to see what's conductive and what's not. And there you go. That is the science of a plasma ball. Thanks so much for watching. I hope you enjoyed the experiment. Don't forget that you can check out our channel for more exciting science videos, and you can leave us any comments of what you thought or what you might like to see. Bye for now.